Every wind turbine begins with wind energy. So where does wind come from? The sun unevenly heats the surface of the earth, warmer air rising up while colder air sinks. This flow of air creates wind. There are two types of wind turbines. Horizontal axis wind turbines are the more common form, and have the main rotor shaft and generator at the top of the tower, the turbine itself facing towards the wind. Vertical axis wind turbines have their main components at the bottom of the tower, allowing for easier maintenance.
Most wind turbines work on a simple system. The energy in the wind turns 2 or 3 blades around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. Wind speeds can determine how much electricity is produced. More gears can also help create more electricity.
Blades are one of the most important parts of the wind turbine because they capture the wind and, using that force, turn the axle. The axle connects to the gear system, which connects with the generator, which then turns the energy into electricity. Several components such as angle, material, size, and shape work together to maximize the potential of the blades, which we found by running different tests and comparing the output of each. In the end, more generic characteristics, such as the airfoil, took a backseat against our own design, showing the unpredictable nature of blades.
To get maximum amount of electricity, the turbine needs to spin faster. There are 3 options. The first is a pulley system, a number of gears connected by a belt. The next is a direct drive when the blades are directly touching the generator by the same axle. The gearbox works by connecting the gears with the axles that multiply the number of rotations when the teeth of the gears are touching. This way, the amount of electricity generated will increase the number of gearboxes. Torque and force will need to push the blades. Each way comes with pros and cons like friction.
The structure of the base is the key component which pulls the wind turbine together. There are so many possible designs and materials, each one with a different benefit and negative. The main idea and question of the base here is it going to be practical and efficient? To achieve this, the base needs to be stable and frictionless, as well as fitting size. Size alteration can be determined by looking at the dimensions of the wind turbine and blades.
Friction impacts the axle because it rubs against support. Friction is a loss of energy through heat. This prevents the whole turbine from spinning smoothly, so you generate less energy. A styrofoam base has a lot of friction. A wood base has friction, but less than styrofoam. The Tektronix base had the least friction.
The future of eco-energy. So what is eco-energy? Eco-energy is another term for renewable energy, otherwise ecology-friendly energy. Renewable energy improves air quality and reduces the carbon footprint. The 4 main types of eco-energy are wind, tidal, geothermal, and solar energy. Currently, wind energy is harnessed with wind turbines, tidal energy with hydroelectric power plants, geothermal energy with geothermal plants, and solar energy with solar panels. Today, New Jersey only uses about 17% renewable energy, which will need to go up. Sources of renewable energy that are not always available have other sources to help out. Currently, there is one big problem with renewable energy: figuring out how to store the energy. In the future, we hope to find a way to store the renewable energy to benefit our environment.